Good evening, everybody. Again, hi. My name is Ian Latimer, Project Manager on NYSERDA's Clean Energy Siting team. And it's my sincere pleasure to welcome you all to the second installment in our ongoing webinar series entitled Battery Energy Storage Systems, Key Considerations for Local Governments. As you can see front and center, tonight's topic is fire safety. We're very excited to have you with us, and again, we'll hope to see you at the future webinars as well. Next slide, please. Before we get too far into it, just want to lay out some housekeeping concerns for tonight's webinar. So attendees have been placed on mute. You'll know that there's an icon there on the right. You'll see that when your microphone is muted. However, we do encourage all attendees to participate by submitting questions and comments using the Q&A feature. So if you want to take a brief moment to locate that feature, you can see it pictured there on the right. A couple of notes regarding your questions that you may submit throughout the webinar. Number one, we highly encourage you to submit them throughout this evening's presentation rather than just waiting till the end. We want to make sure that we can get everyone's questions addressed in a timely fashion. So please feel free to submit throughout the event. As well, if you have any questions regarding material that's included on a specific slide, please feel free to utilize the slide number which is included on the lower right-hand side, just so that we know exactly what you'd like to reference in your question. The chat feature in WebEx has been disabled for tonight's event, so you'll just want to be utilizing that Q&A feature. Today's materials, along with a recording of this webinar, will be posted online on our website at www.nyserda.ny.gov/storage-guidebook. Some of you may know that we've had a bit of trouble getting the first recording posted on that website there, but we do have the link available, and we will be posting that as soon as we can, along with the materials from tonight's webinar and the future sessions in the series as well. And finally, if any technical problems arise as far as audio or your ability to see the screen, please contact my colleague Sal. You can reach Sal Graven at sal.graven@nyserda.ny.gov, as pictured on the slide here. Next slide, please. A quick overview of the forthcoming webinars that will round out our key considerations for local government series. 2 weeks from tonight, we'll be putting on a session focused on zoning and permitting, featuring myself and my colleagues on NYSERDA's Clean Energy Siting team. Following that, we'll have a session dedicated to decommissioning and end-of-life considerations for energy storage systems. We're very happy to feature speakers from DNV as well as Lifecycle for that event. And finally, rounding out the series, we'll have a session focused on taxation and assessments, featuring two speakers from Hodgson Russ, who will be joining us that evening. So if any of these sessions are particularly pertinent to you and your communities or any of your colleagues, please feel free to tune in and to pass the event information along. Next slide, please. A quick agenda for the material that we'll be covering in tonight's session. We'll start with a recap of some of the material presented in 2 weeks ago's Batteries 101 session focused on energy storage in New York State. Second, we'll hear from the New York State Office of Fire Prevention and Control. After that, we'll get to the meat of the night's presentation focused on battery energy storage systems and fire safety. And finally, we'll have a facilitated Q&A with tonight's speakers to close tonight's presentation. Next slide, please. I mentioned we've got some speakers, and I'm happy to introduce them now. It's my absolute pleasure to introduce Jason Ward of the New York State Office of Fire Prevention and Control. Jason's a fire protection specialist within the OFPC's Fire Training and Education branch, where he administers courses on fire and emergency services for volunteer and career departments in the Lower Hudson Valley. And Jason also represents the OFPC to counties across the Lower Hudson, Long Island, and New York City. So Jason, thank you so much for joining us for this evening's session. It's also my sincere pleasure to introduce our colleague Paul Rogers, a founding principal at the Energy Safety Response Group, or ESRG. ESRG works with everyone from product manufacturers to project owners to local code officials to ensure the safety of energy storage resource deployments. Now, prior to founding ESRG, Paul served as an FDNY lieutenant for over 25 years, including time spent as a hazardous materials or hazmat specialist, as well as leading a project on energy storage systems for the New York City Bureau of Fire Prevention. Additionally, Lieutenant Rogers currently sits on the NFPA 855 standard for energy storage system installations and is a member of the International Fire Code Action Committee for Energy Storage Systems. So again, Paul and Jason, it is our sincere thank you for your availability tonight and for, coming to help New York municipalities learn about energy storage systems. Next slide, please. But before we get to that, we'll just do a quick recap of some of the material that we covered in the introductory webinar a couple of weeks ago. Again, attendees that were not able to tune in, please look for the link on our website if you'd like to learn more, but we'll do a brief recap on some of this material. Next slide, please. So really, before we can get too deep into the energy storage conversation, it's worth noting New York State's goals, which are undergirding the effort to, build and develop renewable resources across the state. And really, we're looking at some of the goals that are outlined and codified in the Climate Leadership and Community Protection Act, or the Climate Act, which was adopted in 2019. Now, we're thinking really primarily about a couple of different things. Number one, electricity sector goals. So the Climate Act codified a goal to reach 70% renewable electricity by 2030, which is an increase of the 50% that was previous in place under the Clean Energy Standard in New York. It also codified a goal of reaching 100% emissions-free grid by 2040. Now, in addition to these electricity sector-wide goals, it also established a number of technology-specific goals. The state needs to procure 6,000 megawatts of distributed solar by 2025, 9,000 megawatts of offshore wind by 2035, and particularly noteworthy for tonight's webinar and the rest of the series are energy storage targets as well, including 1,500 megawatts of energy storage by 2025, and doubling that figure to reach 3,000 megawatts by 2030. Next slide, please. Now, a brief overview of, what are we talking about when we talk about energy storage systems? Well, energy storage systems, or ESS, they're storing energy for conversion to electrical energy. And the most common type that we'll be seeing in the state of New York and what we'll be focused on throughout this webinar series are batteries, which are converting chemical to electrical energy. They are the most common and flexible type of energy storage system. If you tune in to, or if you go watch the recording from the last webinar, you'll hear Dr. Stan Whittingham describe some of the other types of energy storage systems, such as pumped hydroelectric or flywheel technologies. But we are going to be focused on batteries, given that they are the prevailing type of energy storage system being used. And specifically, we'll be talking a lot about lithium-ion batteries, which are the prevailing chemistry for energy storage systems that are currently being deployed. Now, when we talk about energy storage systems, we're not just talking about batteries, we're talking about a few different components. The building blocks of these systems are battery cells. If you string a number of cells together, you'll have what's known as a module. If you string those modules together, they'll often be a rack. So those are sort of the building block terminology that we think about with energy storage systems. Another important component is the battery management system, which is a highly sophisticated piece of technology that basically is going to act as the eyes and ears and brain of your energy storage system. And finally, there's the balance of system equipment, which will also include monitoring and safety equipment that's required for these installations. And at the right, you can see a few different photo examples of energy storage systems ranging from residential installations on the top left, which are usually in the kilowatt hour range. There's also commercial installations, which you can see below that, which will range from the kilowatt hour to the megawatt hour range. And then on the right is an example of a grid scale or utility scale energy storage installation. This particular one, I believe, is a 20 megawatt installation that's in the capital region. And these systems will be in the megawatt hour to gigawatt hour range. Next slide, please. Now, when we talk about energy storage, we're seeing them serving a variety of important roles for the electric grid across the state, including a few which we'll just run through briefly. Energy storage systems can be used to defer costly upgrades to transmission and grid distribution infrastructure. They can provide key ancillary grid services, including frequency and voltage modulation rather. Batteries can also support the integration of renewable energy generators, such as solar and wind, based on the time of day and other types of generation that are occurring incidentally when solar and wind are generating. You can also use batteries to alleviate congestion in the grid, which can reduce brownouts and blackouts for our customers. And then finally, electric bill management, as well as backup power for homes and businesses. Those are just an example of a few of the use cases that we've seen for energy storage. If you'd like to hear my colleague Jason Doling so eloquently describe more, feel free to watch the recording from the previous webinar as well. Next slide, please. Now, we talked a little bit about, what is energy storage and why is it being used? Now it's a question of how is it being deployed? And so spend just a brief moment talking about NYSERDA's energy storage initiative, which is just to say that NYSERDA has an incentive program whereby we offer incentives and technical assistance to support the deployment of advanced energy storage. There are two main programs within that effort. There's the retail energy storage incentive, which is for residential through commercial scale projects under 5 megawatts. We've already allocated over 161 million to these projects across the state, with an additional 16.4 million remaining for residential and commercial projects on Long Island and in Con Edison territories. There's also the bulk energy storage incentive program, which is for larger projects over the 5 megawatt threshold. Incentives for that program have been fully allocated, and there's no funding currently available within that. Next slide, please. And then finally, just a quick snapshot of energy storage deployment in New York State to date. As of October 31st of last year, we were at just shy of 100 megawatts of installed capacity across about 560 projects in New York State. However, that only tells some of the story because we've also got a lot that's under contract and in the development pipeline. So as of April 30th, we were at just over 1,000 megawatts that's contracted and under development in various stages of development in the queue. And that comprises over 100 commercial and bulk projects. And with that, that sums up our recap. I'll ask next slide, please. And again, it is my sincere pleasure to turn control over to Jason Ward of the Office of Fire Prevention and Control. Jason, it's all yours.
Thank you very much, Ian. I appreciate it. Good evening, everyone. As Ian said, my name is Jason Ward. I am a fire protection specialist with the Office of Fire Prevention and Control. I'm going to give you just a little bit of an overview of what OFPC actually does and who we are. So next slide, please. OFPC's mission is to be a nationally recognized leader in fire services. We deliver state-of-the-art and comprehensive training, response, and technical assistance programs and services to really kind of all of our customers across New York State, specifically emergency responders, but local entities, governments, NGOs, et cetera, and the citizens generally. Next slide, please. OFPC is one of 4 offices which make up the New York State Division of Homeland Security and Emergency Services. The leader of our office is the State Fire Administrator, Skip Nerney. Within OFPC, we have 6 functional areas: the Special Operations, Fire and Arson Investigation, Fire and Life Safety, Professional and Leadership Development. That's really kind of an internal branch to the office. Educational and operations support, and the fire operations and training. And actually, I gave them bad information. That's actually the fire training and education branch. That's my fault. Sorry about that, Ian. Next slide, please. The Special Operations Branch kind of focuses on technical rescue, response and instruction, as well as hazmat response and instruction. We bring the extrication building collapse, hazmat, training kind of out to the departments, as well as to the Fire Academy, which you'll see in a couple of moments. The Fire and Life Safety Branch does inspections, and they're experts in the New York State Uniform Code Administration, as well as fire and life safety public education to our customers. The branch I work for, Fire Operations and Training, or Fire Training and Education, we do a bunch of different things. One of the main things is we run the New York State Academy of Fire Science in Montour Falls. That's actually where I started my career with OFPC up until August. FTEB also administers the outreach training program. That's currently what I'm working on, bringing basically training out to all of the fire departments across New York State as requested and as necessary. And we're also a liaison between local, county, and state officials. When there's a state of emergency, or if there's a question about training or the fire service, a lot of times those counties and local officials will ask us, and we'll refer that back to Albany or get them the answers that they require. Next slide, please. Energy storage systems have been on OFPC's radar for a hot minute now. In the past, we've kind of been our role has really kind of been to issue or highlight alerts, regarding products containing batteries and those kinds of things, putting out some of those bulletins that some of you may have seen, pushed down from the state to the counties and then pushed out to local entities from there. One of the main areas, though, that kind of a lot of folks in the emergency response arena have been aware of for some time now is electric vehicles, and some of those other like local or mobile battery applications. But that is actually one of the things that we're trying to work on now, is some of those sort of same technologies are becoming more static, more larger scale. And we're developing trainings to ensure that our first responder customer base and the local government entities that use the uniform code are aware of and able to deploy these kinds of systems. We're partnering more recently with NYSERDA, and we're working to become subject matter experts to reach a broader audience. We have a lot more to come as far as those trainings and information from OFPC and directly out to you as the customers. But at this moment, that's really kind of all that I have. So I'm actually going to turn this over to Lieutenant Rogers. Lieutenant?
Hey, thanks, Jason. Appreciate that. And it's now retired Lieutenant Rogers, by the way. Good evening, everyone. So I'm going to go over a little bit of the fire safety and even some of the incident management. And I really want to try to bring you into the mind of the firefighter when you get into the incident management. So for the people that are doing development, you know what the firefighter is thinking. So we can go to the next slide, please. So when we first started to see this coming into New York City, we were looking at the New York City Code, which is 2014, which is it was a modification of the 2012 IFC. And when they first started to come in, we realized that there were some batteries inside buildings already, but we knew they were lead acid based. And one of our biggest concern was we didn't know much about lithium ion batteries, and we really felt that the code did not cover it well. So we needed to start to get some information. So when we asked some people that came into New York City about putting these batteries into the high-rise buildings in Manhattan, we got a little bit concerned because, again, not knowing much about lithium ion, we decided to put the brakes and say, let's try to get some more information. And just to be clear, these people, and I don't think they did intentionally, were telling us that lithium ion batteries do not go on fire. So we were a little bit concerned about that. So we were skeptical. If you can go to the next slide, please. So Con Edison and NYSERDA, who were big proponents of trying to get these energy storage into New York City, decided to do some testing, and they hired a company called DNV. I think they were DNVGL. I think they're DNV now. They started to look at the batteries, and we wanted to know, first in New York City Fire Department, we wanted to know, hey, how did these things fail? And if they fail, what's the hazards that we got to deal with? So the testing was done preliminary. It's one of the first tests that I know that did something like this. And as you can see, the failures that we are aware of, thermal abuse, the overheating, right, and the external heating, the electrical abuse, mechanical abuse, the factory defects, which we started to hone in a little bit more about that. And we still see some issues with batteries outside of energy storage system where you see consumer products that are going on fire quite frequently. And we saw this at this particular time with the hoverboards that were going on fire. So we really got concerned about that. But some of these battery factory defects and the dendrites that are taking place inside, dendrite buildup inside is causing some of these fires. But you see that out there. Just keep in mind, these are not the same batteries that you'll see. Well, they are similar batteries, but the supply chain is not the same supply chain. There is a lot of counterfeit batteries that are coming into those consumer products. So when you see these things on fire, I just want you to say, that this is not going to equate to what the batteries have. Also, we saw component failures was another thing that we looked at. But from the firefighting point of view, we wanted to know, how are we going to protect the people? How are we going to protect the responders? When we're dealing with fires, we wanted to know how hot these fires get. And we realized that these things do get actually hot, but we're used to fire, so that wasn't such a big deal. But again, knowing that these things were really hot, we realized that that could have a problem with some of the fires that may go inside a room, and we needed to get a larger density of water. We also knew about toxicity, but again, getting people out of the building was usually something that we did pretty well in New York City. But when you get into a high rise, it becomes more of a challenge. But still, we said we can work with that. But as far as the firefighters are concerned, they wear SCBA and they had the proper gear to handle any type of toxicity that may come about as a result of these things failing. As I mentioned before, the high heat release, we would just, we usually use a lot of water when we get into these buildings. So we thought that we had enough water, but we still weren't sure on that. We were going to do some more testing on that and get some more information on that. But here's the next one. This fourth bullet right here that says flammable gases. That was one of our concerns. We knew that when these things fail, before they go on fire, they actually had flammable gases that were emitted from the batteries themselves. And that became something that we found really, really interesting and concerning. So we started to realize that maybe we need more than just a sprinkler system in there. And we'll talk more about that later as we go through this particular seminar. And the last thing that we noticed was stranded energy. Even when these batteries went on fire, there was still some sort of stranded energy that was still attached to it. And there were some studies that were done, and there was some incidents where the 787 was grounded, where the battery went on fire, even though the battery for the plane had gone on fire, and they were able to land no problem. So I want to make sure everyone knows that. But the battery going on fire was put out. It did not go back on fire, but there was still stranded energy, and that came of concern for us because now we lost all the safeties, and the battery still contained that energy. So now we wanted to know, well, how do we handle this after a fire? Who's going to be in charge? And who's going to take these things away? You can go to the next slide, please. So the key takeaways on this was the importance of ventilation. And I mentioned that before, that was a big concern of us, getting this gas out of the actual enclosure or out of the room. And we wanted to know, how do we get this stuff out there? We didn't want firefighters to opening up any type of enclosure doors and causing an incident, or maybe a potential deflagration could take place while they were opening up the doors. So we were very concerned about the idea of the importance of actually putting ventilation in there. That also dealt with the toxicity you can get things out of there. And it also, this particular study, they really started to align with plastic fires. So we knew what we dealt with plastic fires. They are hot fires. So the study came out and said these things were similar as far as the heat was concerned as plastic fire, which is a petroleum-based fire, which burns a little hotter than the normal fires that we deal with. We also wanted to know whether we could use water or not, and was water effective? And sure enough, this did confirm that we could use water, and water would work as a good coolant in order to try to stop the reaction from taking place. One of the things that, from the firefighting point of view, is when you're dealing with a lithium, we call it an IUM metal in hazmat, lithium, magnesium, titanium, all of those things are water reactive. So when they do burn and you put water on them, sometimes if you don't have enough water, it could cause a major reaction. And that was a concern of ours. But we realized later that this is not elemental lithium like we're dealing with, not like lithium metal batteries. These are lithium ion, which is more of a salt. So water became very effective, and we felt comfortable using that from that. Next slide, please. So now I'm going to get into the evolution of the codes and standards. When New York City was looking at these things, they were getting a lot of flack from people because they weren't moving fast enough. So we started to have requirements, but these requirements were outside the codes or standards that were currently in place. As a matter of fact, there really wasn't much good guidance on how to get these things installed into buildings or into the outside. So New York City, again, using them as the basis of where everything evolved from, they said, we're going to hold off on putting things on the inside until we get further information. But remember, that was back in 2016, where we started to ask for certain requirements in the requirements for installation of these lithium-ion batteries within the New York City landscape. Next slide, please. So as things started to develop, we wanted to know more about how the product is, and how do we know whether the inverter was actually going to be matched up to the actual to the batteries themselves. So the inverter had a standard on its own. So UL came out with this thing called UL 9540, where it just says that, hey, the system works together, that the inverter is talking to the batteries and everything's working in conjunction as it should be. So this way it's considered safe as far as the way these things interact with each other. So UL generally does what they call a product standard. And from there, we go into the ICC and the NFPA. So if the product were to fail, then this is where we want to make sure that we can protect properly, making sure these things were put out or managed as far as the failures are concerned. The next thing that also came about was destructive testing. Inside the code, they have this thing called large-scale fire testing, but there was no criteria on what large-scale fire testing was. So they needed something uniform. So UL kind of put their heads together and they came up with this thing called UL 9540A. The first edition was in 2017. We're now currently on the fourth edition of UL 9540A, and it has continued to go in the right direction where these batteries are really being put to the test. We really want to know in UL 9540A what happens if they do fail. So it's a destructive test, and they actually look at how the batteries fail and what comes off the batteries, and whether the installation requirements and the fire protections that are put in there are going to be able to manage those things if they were to fail. In 2018, the ICC or the IFC actually introduced a new chapter. Originally, it was in Chapter 6. It went to Chapter 12, and it was dedicated strictly for energy storage systems. And Chapter 12 now in the 2021 IFC is currently what you see in New York State, and we'll get to that a little bit later on. In 2019, the NFPA released the NFPA 855. So I mentioned before about the 2021 IFC and the NFPA 855. The same committee, or most of the same committee that worked on NFPA 855, also worked on the 2021 IFC International Fire Code. So they were aligned very, very closely. If you did a side-by-side comparison, you would see what I'm talking about. But they also brought out that you need to test your batteries up till UL 9540A. And you can see that they have published, the UL has published that fourth edition of that 9540A. And the ICC draft of 2021 also included the International Residential Code. We can go to the next slide, please. So I mentioned a lot about this UL 9540A, and a lot of people have a lot of questions about how this thing actually works. As I said before, it really is destructive testing, and they do it in stages. They start off the module, they get into the, they start off with the cell, they get into the module unit, and then finally in the installation. So it's technically not a listing. All right, it's just a performance test. And if you finished and you get right to the installation, then you finish the testing. If you're stopped at the cell or the module, then you just get the data from there, and you have to go back and redesign if they get to certain areas where they're not comfortable with some of the results. So this testing is really nothing more than a data collection. So they do destructive testing on it, and then they'll collect the data from it. For instance, in the cell test, what they'll do is they'll actually put the cell, and they'll use the cell till it gets into a thermal runaway event. They'll collect the gases, and then they want to know what gases are inside the smoke that comes out, what are the constituents of the smoke, of the gases in the smoke itself, and then so on down the road. And then they'll do in some module testing where they look at the thermal runaway and other flammable gas components and heat and gas release rates, and what rate are they coming out. And this will help to decide what is going to be needed for any type of protections. And this helps for the fire protection engineer to put in the right protections either inside the room or inside the enclosure to make sure that these things are handled properly. And then we get into the unit, and then finally in the installation test, as I mentioned before, where they want to make sure that if this thing does go in, is there effective fire protection systems, and with the heat and gas releases will be measured, and will we have the right type of fire protections in those. Also, we would look at deflagration. I mentioned before, for those who don't know, deflagration means an explosion. If these things were to off gas and that gas would continue to build up, we could have a deflagration, which is an explosion. But the nice part is the NFPA 855 and the IFC 2021 code looked at that, and they were able to put in these things called deflagration venting or deflagration prevention to actually mitigate that deflagration or manage the deflagration when you have deflagration venting holes in there. You can go to the next slide. So now we get into New York State. So New York State did a wonderful job, and I have to give credit to NYSERDA. They sat down with the Department of State, and they said, you know, we really want to try to move some of these things, and we want to move them in safely. New York State was ready to adopt the 2018 International Fire Code for energy storage system. But with the help of NYSERDA and the work that they did in order to explain how the 2021 code worked and how it gave a little to each. It gave easier installation, but it also gave higher protection measures. And I thought that that was a good mix. You know, when I was with New York City Fire Department, I was always trying to be the voice of reason where, hey, if you're going to give me something, I'm going to get something on the other side. So it worked both ways, but we felt that that one, since it was aligned with 2021, that would be a good one to take. So in 2019, the NYSERDA and the Department of State looked at the 2021 International Fire Code that was not out yet. They got permission from the International Fire Code to use that, and they started to put that out there. In my opinion, I felt that that's the best code that's out there currently to date. There was a good job by the state to actually do that. In 2020, they actually adopted into the code. In 2019, it really became an emergency adoption, and then in 2020 it was adopted into the code. So there was a lot of work that was done to make sure that that was the best code for safety, and also give more options to people that were actually putting these things into installations within New York State. And also we started to touch into the residential code, and that also came out a little early. That was part of the 2021 residential code. And we got into a little bit on the building code. So all of these codes were actually affected as a result of this new adoption of the 2021 IFC in 2020 for the uniform code in New York State. You can go to the next slide, please. So back to the uniform code and the residential code. So in the 2020 New York State residential code, they looked at the size and the separation requirements for these energy storage systems that go inside. As you can see the picture on the right-hand side, you can see that's installed inside a garage. And there's certain criteria if you're going to put it inside the garage. But anytime you go on the interior, the highest amount of energy that you can put in there is 40 kilowatt hours. No unit could be more than 20 kilowatt hours per unit. And the highest that you could have when you're putting it inside the dwelling itself or inside the building itself, when you're dealing with a private dwelling or a residential code, is 40 kilowatt hours. When you get into the outside, you can put up to 80 kilowatt hours, and you must just follow the prescriptive code in order to do that. For instance, the separation distance from each unit has to be at least 3 foot, and it also needs to be 3 foot from the windows and doors or any type of egress that is there. Fire resisting ratings also need to be on the roof, so you can't have any roof that is open to the air where you have no sheetrock or any type of gypsum board above it. So fire rating is going to have to be on the walls and ceilings of the room and the areas containing that ESS. So if you have these things inside your garage and the ceiling on the garage is not does not have any gypsum board on there, that 5/8 inch gypsum board, you're going to have to put that up there in order to comply with the code. And also the protection from the impact. Certain requirements may be modified based by the AHA based on large-scale fire testing. So if someone did their homework, and we'll talk even outside of lithium ion, maybe it's a different chemistry, but if they did their homework and they did some large-scale fire testing, and it really shows that there is no concerns when these things fail, whether they don't go on fire, or there is no fire contained, or there's no any type of explosion or anything like that, then why should they be held to the same requirements as everyone else? So they realize that that's an issue. So the code committee said, okay, well, we're going to give some authority to the authority having jurisdiction, which is your local code enforcer that's going to be the one that's going to approve these installations. They said if they can do some large-scale fire testing and show that it is safe, then that local code enforcer can actually have these things put in there. Some of the, or could modify some of the things that are required in the code itself. You can go to the next slide, please. So then back to the New York State Uniform Code, Chapter 12. One of the requirements that may be needed out there if you're putting some installations in there is a hazard mitigation analysis. What that is a failure modes and effect analysis, an FMEA. And they just want to know if this thing were to fail, what mitigation is in place, and what happens if this component were to fail or something else were to fail, what takes place. So that is required on some installations for that are large scale. And there's other requirements in the code that mention where this HMA, which will spark an FMEA, where you're going to have to do that. It also, as I mentioned before, it evaluates the consequences of the ESS and the failures and what protection places are in there. So just a little word for those people or any AHJs that are out there, that there's a lot of layers of protection inside here that need to fail in order to have a failure. So if these things were to have some sort of overheating, there's a lot of mechanisms in there to make sure it doesn't go any further than a certain temperature. So we do not ever get into a thermal runaway effect, and we do not have propagation from cell to cell, which is good. And I always looked at that when we were in the New York City Fire Department. We always asked questions about the cells and propagation and how these things could fail, and what do you have in place in order to prevent it from failing. And engineers do a really good job on trying to make sure these things never fail. But as a firefighter, and any firefighters that are in the audience today, we know that when we show up to an incident, we're always saying, hey, that wasn't supposed to happen. So these things do fail, and it will fail out there, and we'll see that. I don't think we'll see it on a large scale basis at all. Matter of fact, it will be very minimal, but there's a potential of something failing. Getting back into the large scale testing, again, for the uniform code did put in there large scale fire testing, and they did adopt that 9540A would be the large scale fire testing or an approved equivalent. So if the AHJ or code official, if you were to go with some sort of test that is equivalent to 9540A and it was approved by the authority having jurisdiction or local code official, they can adopt that and say, yeah, we're going to approve that testing. Even though it's not 9540A, we can approve that testing, and we're going to allow that installation based on the testing that you did that may be outside of 9540A. I haven't seen it done yet, but still there is that provision in the code. That came about because 9540A at that particular time, there was still some issues that UL was trying to iron out, and they did a great job on making sure that they did iron that out. So again, the large scale testing will demonstrate that the fire will not spread to adjacent areas outside the room. So it's got to be contained within the room. And again, they will show that will come up in the testing that this fire will not go outside the room or the area in which it's inside of. And we mentioned that it's a data collection test. This is exactly where they get all the information they need and the data to support the protections and the requirements needed to make sure that we can manage these incidents in the event that they go on fire. And it is required for systems that are more than 600 kilowatt hours. And that was a threshold, that's a maximum threshold for lithium ion in the code itself. For other chemistries, there's slight differences, but for lithium ion, there is 600 kilowatt hours. You may be able to go, you're going to be able to go more if you get that large scale testing. So I've noticed that there's a lot of people that are actually doing that large scale testing and bringing the results to the AHJ for the AHJ to take a look at, so they feel safe that this thing can go inside their jurisdiction, whether it's indoors, outdoors, or whatever the case may be. You can go to the next slide, please. Another thing that was put into the New York State Uniform Code that also matches, as I said, 855, and this was something that we looked at in the New York City Fire Department. We realized that these were very technical systems and that a lot of the firefighters would not have a good idea on how they work, and not all of them were going to be uniformed. And since they were going to be unstaffed outdoors, there was a concern that the firefighters may need some help. So what we did is we started to require that there be some sort of fire remediation put in place, some team to actually come and help the responders. And they would come as a result of the fire department on the scene showing up and saying, we're not familiar with this, or we don't know what's going on, if they felt they needed that help. So they would be there more to support the firefighters. They're not there to put any fires out. They're there to support the firefighters and start to integrate in the incident command system, where they'll be able to give advice, and good advice, to the incident commander so they can make a more educated decision. As I said before, firefighters have a lot to do, and this is a very technical area, so they won't know much about these things, especially when they're not going to be uniformed installations in different types of systems, that they felt it was best that they get someone there. And there should be a number available to actually have the incident commander call in the event that they need those people there. Another thing that was put in there is a peer review. So since it's very complicated and the UL 9540A data and the testing report is extremely technical, the AHJ may have some issues on trying to understand this. So the code says if the AHJ requests a peer review to take a look at some of the stuff that's going in, whether it's the 9540A test whether it's the installation itself, they can actually retain a peer review person to take a look at it and making sure that these things are in properly. And if there's anything that is outstanding, they'll have to address it with the installer itself. Another thing that was put in there is the commissioning plan. And this really dealt with making sure that these things went in properly and they were working right. And there was also an operations and maintenance manual. We noticed that a lot of these UPS systems, as I mentioned before, the lead acid based UPS systems that I've been on a couple of calls on, most of the time we went on any type of calls with these things is because of the lack of maintenance with the batteries themselves. So that was something that's pretty near and dear to most fire departments and AHJs, and making sure that you have a robust operations and maintenance plan put in place. But the commissioning plan will make sure that that operations manual is there, and you have to make sure that everything is working prior to you going online. So if the alarm system is not working where the fire department can't be notified, then you're not going to go online until that is actually completed. So all that stuff needs to be done, and needs to make sure that if you did have if there was an event, that everything is working properly. We have another slide going into decommissioning plan, but in the event that there is an event or the end of life of these batteries, how are we going to get these things out of here? How do we remove them? And how do we remove them in the event of a fire? And I have another slide on that, so I'll get a little bit more in depth in that as we go through this. Next slide, please. All right. I'm always big with these matrices. I think they do a good job and tell you where to go and what you need to do. And you'll see a lot of that in the New York State Fire Code, and you also see it in the NFPA 855. But one of the things I really want you to hone in on is the section that says other energy storage and battery technologies. There's clear prescriptive criteria on what to do in a lead acid or a nickel cadmium or a nickel hydride, lithium ion, or a flow type battery. But when it comes to other ones, a lot of people don't know what they're going to have to do. And even in the fire department, they don't know exactly what it is. But there is going to be other chemistries that's coming in. I can guarantee you that. I know a couple myself that are looking to make a play into the market. And they're asking, how do they get into a code official? How do they explain it? So they have to tell their story to make sure that if they're going to go into the code official and the code official is going to allow it in there, they're going to have to really articulate that this thing is not a fire or safety concern. And they may even have to do some sort of 9548 testing on that too. So these things I think are really helpful for people that are want a quick size up on what they need to do if they're putting an installation in based on the chemistry itself. You can go to the next slide. All right. In the New York State, they have installations that are going to be indoors and installations that are outdoors. Now, I'm sure a lot of people are looking to do work in New York City. I want to be very clear right now. New York City does not allow lithium ion indoors, right? But they are working on a code. I'm doing a little bit of work with them on that, and they are going to be putting something out very soon for public comment. I'd say in the next couple of months. I never should say when it's coming out, but it's going to be coming out soon. And the nice part is the New York City Fire Department, along with the Building Department, is really starting to look at indoor installations. And I think it's a good thing. Currently, there's not any indoor installations that they're aware of. But the state, when they adopted the 2021 IFC, which is now the 2020 Uniform Code, they allowed for indoor installations. They allowed it for what they call dedicated use buildings, where if you take a look at the top left-hand picture there, that would be considered like a dedicated use building, where there's nothing more than batteries inside the building itself, and maybe an office for administrative purposes inside the building. But those dedicated use buildings, I know myself, it's a lot of them that are looking to go into certain areas in Long Island, where I'm located, and also within New York City. But until New York City has direction on that, they'll probably have to wait for further guidance on that one. And non-dedicated use buildings, things that are not considered all batteries, where it's going to be maybe an office building, and the batteries would be part of that location. Outdoors, they break it down into two sections in the outdoors: things that are near exposures and things that are not near exposures, and they call that remote. And An outdoor remote would be anything that's 100 feet away from the building or the property line. And some people miss that portion. You have to make sure that you're not close to the property line. And they even clarify, I think it's 100 feet from a buildable property line. If that's the case, then you get a lot more leeway on how you get the put these things in to that particular installation. There's not as many criteria involved with an outdoor remote installation when you're dealing with enclosures. You can go to the next slide, please. So now I'm going to talk a little bit about incident management. And this is something that is very near and dear to my heart. And I've done a lot of thinking about this and how do we move forward on that. And as I was working with the New York City Fire Department, one of the things that I did is I represented the people in the field. They were always asking me questions. And it took a long time before we were able to come up with some guidance for how to handle these battery storage. And we're constantly evolving as we learn, but we didn't have all the information, and I didn't want to put something down on paper where I didn't have all the information. So, you know, my boss wasn't yelling at me, but he kept asking me, like, do you have something ready to go for a standard operating procedure on that? And, you know, the chief of department also asked me about that on a couple of occasions. I just said, we're not there yet, because these are very technical systems and we needed to find out more. But incident management is always something that we need to look at. And for all my code officials that are out there, or people who are putting these installations in there, you know, you may want to look at it from two levels, right? You want to look at it from how these things will be put in according to the prescriptive code, and also how is the fire department going to come in there? What safety do they have? And that was something that was very, very dear to the New York City Fire Department. Not only did they want to have the rule that's currently in effect, make sure that you comply with the rule, but they wanted to make sure that the firefighters are actually kept safe. And there was a big reason for that. And we did a lot of due diligence to make sure that the codes or the rule in New York City and 855 and the International Fire Code also protected the firefighters. You can go to the next slide, please. So for those who don't know, and when you have a call in the fire department for an electrical emergency, or the chemicals or the hazmat, that's the two things that the fire service really has a tremendous amount of respect for. They don't like to mess around with any type of electricity, and they definitely don't like to mess around with any type of chemicals. So what do we have with batteries? We have electrochemical, right? So now we're dealing with two of the things that we just don't like to see at all in a fire event. We also know that when we do shut down any type of emergency with an electric, we'll shut down power. We will not operate until we know the power is shut off. But when you're dealing with batteries, shutting these things down does not release the energy. And that became a major concern from the operational side for the firefighters, that energy gets isolated in the actual enclosure or in the battery or in the system itself, and it doesn't go anywhere. It gets isolated there. And that's what we mentioned before about the stranded energy. You can go to the next slide, please. So with that being said, New York City had required certain criteria, and we looked at certain things that we wanted in the for incident management. And as a result of that, we probably hit the mark right, because it was an incident that took place in Arizona. But before I get into that incident, and some people may know about that incident already, but that really put the fire departments, for people to consider the fire departments, really, they needed to start to take a look at that. But there was also an incident that took place in Hawaii, where they had a fire that took place, and the fire department really didn't know what to do. Again, these were batteries, and they didn't know how to handle it. What's the right extinguishing agent? How do we handle these things? What should we do? There was also another one in Wisconsin, where they went to a battery manufacturing place. So the fire department did the right thing, and they went up to the people and they said, hey, what's burning on the inside? They said lithium-ion batteries. They said, okay, what do we need to use in order to extinguish it? They were given direction that they should be using foam. So what they did is they called the airport foam truck to come in. They waited a couple of, probably about 45 minutes for the airport to dispatch its foam truck to the incident. They sprayed foam in there for about an hour, I believe it was. And then sure enough, didn't put it out. So they wound up using water. And guess what? I think it burnt out. They said they put it out, but I think it actually burnt out. All the energy actually burnt out. And other things that we saw with the electric vehicles, that we see those things going on fire. Not often, not often. You know, there was just one incident that took place in Houston where a Tesla went on fire. And what people need to understand, if you abuse these things, right? If you abuse any type of lithium-ion battery, yeah, there's going to be a problem with them. You know, I like to call them the Goldilocks battery. Everything needs to be just right. But if you're an electric vehicle and you're going 90 miles an hour and you hit a tree, expect something bad to happen. But the problem was the fire department had a tough time putting out the batteries. And I would expect that to happen, right? They don't really have much access to the batteries. They're underneath the chassis of the car. And then they don't have a direct shot to put those water on there in order to cool the batteries. And then, as I said before, the consumer electronics that we see out there, some of these things are going on fire. And that's a concern of mine because like these hoverboards were actually banned at one time from the New York City subway system. I'm not sure if that ban is still there, but they were concerned about these things going on fire when they were inside a subway car. Or just recently, they had one of those scooters, electric scooters, inside an elevator that went on fire while the elevator was in movement. I don't think there was any fatalities, but still, it's a concern. But again, don't equate these to the energy storage system. There's a lot more layers of safety, and even the supply chain is different. The reason that you can buy one of these hoverboards, you can buy one for $50 on Amazon, or you can buy one for $15. It probably has to do with the idea that the battery, so the quality assurance of that battery, that one for $15 may not be as high as the one that's for $50. So now we get into a little bit what happened in Arizona. There was an incident that took place in Arizona. You can see it up on the top right-hand side of your screen. That was an incident where the firefighters were called to the scene, and they said they were notified that there was lithium-ion batteries. They wound up taking a 2-hour size up. They went around it a couple of different times. They called in the hazmat unit, and nothing was showing on the outside. And that becomes a concern for the fire service. If it's on fire, guess what? We know what we need to do. We need to put water on it, right? But when it's not on fire, that's when it becomes a major factor. Well, what do we do next? How do we handle this thing? So they were concerned about going on the inside of this because they knew there's lithium-ion batteries, and they had a little education, which I was kind of surprised. But this installation here was not really installed as according to the, well, it actually was installed according to the codes, but the codes were weak at that time. So there was very little criteria that was needed. But these things, going back to the fire department, they stretched a hose line, they charged it with water, but they never actually wound up using water on it, from what they told me. But as you can see, the open door with the char mark above it. Eventually, the fire department said, "All right, after 2 hours, let's see what goes on. Let's open it up and see what goes on inside." So they wound up opening up the door to the location, and out trickled the smoke, a white smoke that hugged the ground, and there was two firefighters that were standing right in front of the doorway, and they said about 3 minutes. They never planned on going inside it. With about 3 minutes, there was an overpressure that took place that actually blasted firefighters back into the fence, and then one firefighter was blown 75 feet. And it goes back to what I said before. How did the firefighters get the gases out of the container, or out of the room, or out of the enclosure? And that became a big concern. And in New York City, we asked that question prior to this incident taking place. And New York City does ask for some way, explain to them how that gas is going to get out of there, right? And sometimes people don't have such a good answer. Sometimes they do have a good answer. So the New York City Fire Department, again, is very open to people, innovation, and suggestions. But a big concern for the fire service is an explosion. We don't have personal protective equipment to actually handle explosions. So we saw the results of that, and as a result of that, that really put the fire departments on notice that these things could be a challenge for them if there wasn't a failure. The nice part is there's not too many failures, but this one really was really looked at by both DMV, who did a report, and UL did a great report. Both of them did a good report explaining that. And if you haven't seen it, I would suggest you read it. It will give you an idea of what the firefighters actually did and what took place. And some of the key takeaways in there is there was a lack of gas detection. So I'm this way and that way about that particular thing, gas detection. Sometimes when these gas detection, the gas detector could get saturated and it can continue to beep all day long because it can't clean itself out. So gas detection is not a requirement in the code. But some people put it in there as an extra layer of safety. And I'm not saying to take it out, I'm just saying I'm a little leery about it. But also there was an emergency response protocol. There was no emergency response that this is the first time the firefighters actually saw it when they were there, like what the heck, what's inside of it. So there was really no training for the firefighters at all. Another thing that wasn't there was any type of deflagration or mechanical venting in order to get those gases out, as I meant before. So if there was a deflagration, that deflagration could be managed through a deflagration venting hole, or it could be pulled out by deflagration prevention fans and what have you. And another thing that was in there was clean agent fire suppression. There's been a lot of data out there that shows that clean agent may not be effective for lithium ion batteries and putting them out. It may be effective for components though, which is a good thing. But as far as lithium ion batteries concerned, there is no data supporting that clean agents will do a good job on extinguishing the batteries themselves. You can go to the next slide, please. And back to incident management, as I said before, if they are on fire, the fire operations people, right? As I said, this is an easy day for them. If it's on fire, they know exactly what they need to do. It's going to be tough for them to put that fire out. I'm not going to lie. It's going to be really difficult, especially if it's contained inside the enclosure itself. We want the firefighters to take more of a defensive operation. We really don't want them getting interactive with these things because of stranded energy, potential of explosion that could take place, and also the stored and stranded energy that's already in there. But their goal is to make sure that if there is many enclosures, I will use an outdoor system, if there's many enclosures involved and there's one that's right next to the other, we just want to make sure it doesn't propagate from enclosure to enclosure. There's a good chance that if this thing is on fire in one enclosure, we're not going to be able to save it, right? That thing may go completely either up in flames, or it's going to have so much heat in there that the stress from the heat may actually ruin the batteries that are in the enclosure itself, and they probably won't be able to use again. So just keep that in mind. So that's what the fire department is doing, is they're looking at making sure that it doesn't continue to communicate or propagate to the adjoining enclosures inside. And that's the guidance that's been out there now. If there is no fire, this is where it becomes a big concern. What do we do next? Can we leave? Can we not leave? Where do we go from here? So they may be able to get some information from the battery management system, which really detects heat and detects a lot more things than heat. But one thing that the firefighters are always concerned about is, hey, is there a rising temperature? And if there is a rising temperature, that means there's a problem. That means that we got a heat signature and something needs to go up. Something needs to be done about it. So is that trending temperature that's being monitored or managed or through the BMS, is that continuing to rise? And if it is, that's a concern for the fire service, even though they may not see anything on the outside. So they may need to get some of that information out of the battery management system, which is instrumental. And Ian had mentioned that before. That battery management system, as I said before, really tells the state of the health of the battery. If there's a problem, hopefully we'll be able to see it through that BMS. So that we got to make sure that that BMS is rigorous, right? We got to make sure that maybe has some sort of seal level, that that thing doesn't fail easily compared to the rest of anything else that may fail. Another thing that we wanted to know, if there is smoke with no fire, there possibly could be an explosion concern. And as I said before, when we were looking at these things initially, we knew there's a potential of explosion. So what we wanted is to make sure that we manage that explosion, right? We manage the explosion so none of the firefighters were to get hit by the overblast in the event that an explosion would take place, or even if the debris were to come out, that debris would not actually be projected toward the firefighters during their operations. Next slide, please. This is just a quick slide. When I first was doing my due diligence on this with the New York City Fire Department, I wanted to see what the emergency response guide had to say about this. And in the, for those who don't know, an emergency response guide is basically something that used in hazmat. For every firefighter has to go through a basic hazmat course, and this becomes their book in order to give guidance at any hazmat incident until a hazmat unit were to show up and they're more trained in the hazardous materials. But this gives some sort of guidance. But there was some information in there about lithium-ion batteries, and they changed it. But originally it said, do not use water with these things. No water should be used. You should be using foam or dry chem extinguisher. And it still kind of does point to dry chem extinguisher, but they added water, which I thought was good, and it still mentions foam. But that was corrected. It also talks about ventilation, making sure you evacuate. And when we say evacuate, we're talking about evacuation from impact from a potential explosion. If you're nowhere near any people or anything like that, then you know what? We don't really need to evacuate. And this all comes down to the incident commander making a decision based on that fire remediation team or subject matter expert that may come onto the scene himself and give that guidance to the fire department. Like, hey, we may need to have this blast can go out 100 feet. So anything within 100 feet or 200 feet, I'm just using round numbers here, I have no idea. This blast may impact people in the immediate area of 100 feet. So you may want to just think about possibly moving those people out of the particular blast zone or area like that. It also gives information about fire response and spills and leak. You can go to the next slide, please. So this is what I mentioned before, incident response and the decommissioning. This becomes a challenge for the incident commander. If it's an end of life removal, guess what? It's planned. The energy is either dissipated or it's down to very, very minimal levels. We don't have to worry about it. So it's a nice controlled removal of the actual system itself. And that's what we want to see, where these things no longer have the capacity and they got to be replaced with something else. So we can decommission those things with no problems at all. It's just when they go on fire, that's considered an emergency removal. That's an unplanned removal, right? And this is now we have the damaged equipment. We may have safety issues as a result of that damage. There may be an investigation involved with it. So this may all be time consuming. And one thing that the fire department doesn't want to do is they don't want to leave their resources at a place for 10, 12, 24, 32, or whatever, numerous hours, because it just puts a gap in the fire protection area. So the fire department may want to make sure that someone's going to take over the scene. And if in the event that these things go back on fire, because that could happen with lithium-ion batteries, they could go back on fire hours later, they would be called back to the scene. But they want to make sure that someone is qualified in order to give that information to the incident commander, and also that when they're doing a decommissioning, that the plan is put together, that the incident commander or the fire department or the code official, I'm not sure, either one of them are going to be looking at this thing and approving that is a safe plan. And if it's getting it out of the building, they want to make sure they have that safe plan in place before they actually remove any of these batteries from it. You can go to the next slide, please. Okay, I think this is up to you, Ian, and thank you, everyone.
Yeah, thank you so much, Paul. And the last thing, just before we get to some time for Q&A, if you want to take just a brief moment to write down any lingering questions that you have, and my sincere thanks to those of you who have already submitted questions throughout the event. While you're doing that, I'll just give a quick plug for NYSERDA's resources for local governments pertaining to energy storage systems. And just a reminder that we will be going over these resources in much more depth during the next session focused on zoning and permitting. The model or the Battery Energy Storage System Guidebook has been around since 2019, and it contains a few different key resources, including an adaptable and customizable model zoning law to regulate energy storage installations within your community. So building on top of the protections which are already available without the need for local adoption as a result of the 2020 Uniform Code Cycle update. We'll also cover the model permit and inspection checklist for residential and small commercial energy storage installations. As well as review of some of the uniform code provisions that we touched on in tonight's presentation, as well as some additional ones. We'll go into a bit more depth there. As well, just a reminder that NYSERDA's Clean Energy Siting Team is available to work directly with communities. We provide free technical assistance and resources to municipal boards and local officials. So if there are any questions that are lingering within your community and you can benefit from additional information, or if you're considering adopting local regulations and processes to regulate these systems, let us know. We're happy to help, and we do offer accredited trainings for code enforcement officials and planning and zoning members as well. And so with that, we'll give it just another brief moment for some additional questions to come in before we go ahead and start addressing Q&A. If you could go to the next slide, please, and we'll hold there. And we'll give it just a brief moment before we go ahead and get started. All right, so Paul, we've got a number of questions coming in, and I'm happy to get those started with you. Paul, I don't know if you're interested in turning your camera on to show everybody your face. If not, no worries. But there you are. Hey there, Paul.
Hey.
So we've got a number of really great questions, so I'll go ahead and jump in. First question, Paul, I think it would be really beneficial if we could sort of address the question of are all batteries created equal? And what is the service that's really being posed by UL listings for some batteries as compared to others that are not listed? You mentioned the difference between some of the batteries that we see in consumer electronics versus these energy storage systems, if you wouldn't mind expanding on that a bit more.
Yeah, so when you're putting in batteries on a large scale like you are with the energy storage system, there has to be some sort of listing on those. But if you're doing in consumer products, there may not be any listing on any of those batteries at all. The car industry has done a great job of making sure that those batteries are safe and secure, and the supply chain that's going into the car industry, they don't want to see an incident take place, right? They have a vested interest to make sure that their cars do not go on fire. And the same with the energy storage system. You have people that really want to make sure that these things never go on fire, because it just would, not only would it hurt them, but it would also put a black eye into the industry itself. But some of these, cheaper consumer products that are being made in parts of Asia are coming into the United States, and they're not, they're putting, they are coming in with what they call counterfeit batteries. And I sit on an FAA DOT committee on lithium-ion safety batteries, and these things are being transported over from Asia. There's very big concerns with the pilot industry, and we're looking at this whole supply chain and how do we actually clean that up. Just a little side note about some of the work that's being done on the outside of energy storage, just looking at batteries themselves, how they're coming over.
Thank you, Paul. Yeah, I think it's really helpful to understand, where we see that sort of trickle in of those more problematic counterfeit batteries, like you say, in consumer electronics, as opposed to, like you say, the more stringent UL listing requirements that are required for, all of the technologies being used for storage. So thank you for covering that. Sort of a question about the characteristic of battery fires, and maybe specifically lithium-ion battery. When we see these fires, would you classify them as slower burning, explosive? Obviously some of that's going to depend on things like ventilation, but would be curious if you could sort of speak to the characteristics of a lithium-ion incident.
Yeah, that's a really good question, and I was remiss by saying that. But we noticed that when these batteries, when these lithium-ion battery cells do go on fire, they're going to come out as a pretty intense fire with a lot of pressure. It's almost like a pressure fire, and it's going to be very hard for you to put out, even if you were able to get access to the batteries themselves to get the water directly on the batteries, which is our challenge, right? If you're going to be outdoors and you're going to have these batteries that are in watertight modules, or these cells are in watertight modules in a watertight enclosure, and how you're going to get the water on the inside of these things. So that becomes a challenge. But these things are very intense, and that intensity also is based on the state of charge of the batteries themselves. High state of charge, more energy that needs to be released.
Wonderful. Thank you, Paul. We had a question from relatively early on that I think, is a super helpful thing just to understand conceptually. Would you mind, obviously stranded energy as a concept is not something that's limited to energy storage applications, but would you mind maybe sort of expanding on what stranded energy means and why it's a particular concern for firefighters and first responders?
Yeah. So stranded energy is where the energy gets trapped, right? It gets trapped within the actual cells themselves, or within the module that has a group of cells, and it can't go, it's not, nothing's coming in, but nothing's coming out. So it basically is stranded inside that particular component. And when you have a failure, generally a failure, there's heat involved with that. And when you have heat, you could actually have damaged some of the safety mechanisms that stop these things from going into any type of thermal runaway, or prevent it from going into any type of other failure. So that stranded energy is something that the firefighters still need to deal with, because that energy has not been dissipated. As I mentioned before, that anytime you're at an electrical event at an operation, the first thing that we do is we shut power down. Power is shut, and that communication is made out throughout the field. Power is off, and then we start to operate. But in this situation, we cannot turn the power off.
Thank you, Paul. Really, really helpful. Let's see here. We got a question about the testing piece. Basically just saying that, lithium-ion battery cells can kind of vary depending on size. There's different sort of formats that these lithium-ion cells can take. Is it necessary to test, every size of battery energy storage system from a particular manufacturer? So let's say you've got, a battery manufacturer that has a residential product as well as a larger scalable commercial energy storage installation or product rather. Is it necessary to do that 9548 testing for, all of those sort of range of products?
Well, that really comes up to the comfort of the DAHJ. In certain areas, yeah, they're going to request that you have to have it done, right? In order to move forward, you're going to make sure that you have this this 9548 testing done. But again, it's really up to the AHJ. Are they going to put these things in there when they haven't proven themselves? Well, maybe, well, I shouldn't say they haven't proven themselves to be safe, because they may be very safe. Maybe they just haven't gone through the test, but they kind of keep trying to keep everything uniform, where you're having the exact same test for all the different uh, energy storage systems that are out there. And what comes out as a result of that test is really going to show whether you have the proper safety features in place, separation distances, or whatever it may be. So, large scale fire testing, that was debated back and forth in NFPA 55. How do we do this? And it was also, once we started to get traction with 9540A, we kind of put that into the code.
And Paul, one more thing on that point, and please correct me if I'm wrong, but my understanding, as we've sort of seen UL 9540 and 9540A evolve over time, I believe the newest edition of the UL 9540 listing will require that 9548 testing, right? And so, we expect moving forward, given that these installations are required to be UL 9540 listed, that compliance and having undergone that 9548 testing will have occurred to receive that listing. Is that right, Paul? Can you clarify?
Yeah, that is the case. So the second edition of UL 9540, without the A, UL 9540 will require in certain situations that you must go through UL 9540A. I believe it's in a remote location. They may not require that you do 9540A, but in indoors or things that are next to exposure, they're required to do it in order to get the listing of 9540. And don't quote me on that in the remote. Here's the problem is that any energy storage, unless you're going to put all your energy storage in a remote location, then you may be able to say, well, we're not going to do 9548. But once you start putting it in there, it's going to require that 9548 be done.
Perfect. Thank you. Thank you, Paul. Let's see, we've got some others. Here's a great question for our communities. What equipment might a fire department have on hand or look to procure from a project owner in order to respond to an ESS incident? Thinking particularly in the context of rural and volunteer fire departments. If you could expand on that, that would be wonderful.
Yeah, we gave this a lot of thought too. Like, what are we missing in the fire service in order to actually manage the incident, these things properly? What can we do? And I would say it's not a tool, but one of the biggest things that needs to be done to the fire service, and this word is getting out there, is Department of Energy knows this, is that we need to make sure that the firefighters are educated and trained on these and have respect for them and take a defensive operation on these things, and know that there's always a potential of something that could deflagrate, and making sure that whoever the incident commander is that they call for that help when they're not sure what they need to do. That's really, really important. That's why it was put in there to the code. It was put in there specifically to help the incident commander to make a better choice in his operations decisions.
Perfect. Thank you, Paul. Let's see, next one here that I was just looking at. It's a great question. So the question is there a list of specific safety measures that are required for each battery type or brand? Thinking about, if maybe a developer or if someone has a particular system or a particular technology that they're often using, is there any way that they can know exactly what's required for that product? And I mean, the answer is that, within the uniform code, the requirements are going to be based on the technology being used. So based on the battery chemistry, that's really what's going to determine, what are all the individual requirements that you need to meet to ensure the system is installed safely. And additionally, the 9540A testing that these systems are going to be undergoing, that data will be used to inform system design and what kind of mitigation or fire prevention requirements need to be enforced based on what was demonstrated in the fire testing. So the answer is that there's no one place that you can look to know requirements based on the brand or based on the product. It's really going to be, uniform code compliance based on the battery chemistry, as well as, what the AHJ will require if it's not explicitly required within the uniform code, and anything that they want to go above and beyond or not based on the 9548 testing data. Let's see here. We've got a few questions that are a bit code specific, and I definitely want to make sure we get to those. But I want to make sure if we have any sort of broader questions that might be, helpful for communities. Paul, question about, are there any remediation teams in Western New York, or if you could maybe speak to the availability of remediation folks across the state in various places, that would be great.
And I don't know of any that are out there. Some of the work that my company is doing, we were looking at that, because some of the places are in need of that remediation requirement in order to do that. And these people need to be subject matter expert, right? You can't have someone who is an expert in one thing coming in giving incident command advice on what an energy storage system, how it works, how it fails, what's involved with the actual storage unit itself, because at an incident, right? And I've been at many incidents. These things they're finicky, and there's a potential of a big impact as a result of doing something that may not be proper, and also getting firefighters hurt. And there's some big liability when it comes into that. So I guess my answer is that not that I'm aware of right now.
Thanks, Paul. Let's see here. A couple of the specific code questions we may, need to answer directly to folks just to make sure we have enough time to respond to some of the others. Let's see here. Paul, if you could clarify, when we're talking about lithium-ion batteries, there's sort of a couple different types. You've got the oxides and the phosphates, right? And so we're wondering if there are any different requirements based on the battery being a lithium ion phosphate, or like an NMC, a nickel manganese cobalt battery, or generally speaking, are the requirements going to be the same regardless of the lithium ion chemistry being used?
Yeah, great question. We looked at that too within the New York City Fire Department, because some people started to come in with chemistries that were lithium ion based. They were in the lithium ion group, but they were not as energetic as the other ones. So they wanted some relief as a result of that because of stability. But the code committee, along with the New York City Fire Department, when I was working there, we said, well, the hazards that evolve from a failure, regardless of what the chemistry is, are still going to be similar, if not the same. So they did not give any relief on any of the chemistries within the lithium ion sector itself. Everything is going to be handled as if it's just lithium ion. Same thing with the operations too.
Awesome.
The fire department operations, sorry.
All right, and here's a question. Basically, the asker is asking, if a battery system is designed with like a specific enclosure, like a non-combustible enclosure, such as a steel container, and it's equipped with, some type of a coolant or a fire suppression system, does that change the requirements to have that system undergo large-scale fire testing, such as 9540A?
That does not. What that should be done is, if they feel they feel pretty confident about what they put together, they should actually go out and test. And that's the whole reason for 9540A, is prove that your chemistry is safe, or the fire protections that you have in place will be able to manage it and keep this thing safe, so there won't be any type of propagation or major events that take place from the impact as a result of the failure from an energy storage system itself.
Perfect. Thank you, Paul. I know we've got a few more sort of code-specific questions, and we definitely want to make sure that we get those answered, but unfortunately we are out of time tonight. So if you wouldn't mind, if you have some specific questions, please reach out to our team, especially on these code questions. We know it's a new material and it can be pretty complicated. You can email us directly using the email seen on the screen here. It's cleanenergyhelp@nyserda.ny.gov, or reach out to a member of our team directly. We're more than happy to talk through some of these code questions, as well as other questions you may have regarding energy storage installations. So if you wouldn't mind going to the next slide, please. And just want to give a quick plug. Again, we'll be back here in 2 weeks to talk about zoning and permitting, including a more in-depth walkthrough of the resources contained in our energy storage guidebook for local governments, which, relevant to the codes questions, it does include all of the relevant uniform code citations for energy storage systems. So We'll be happy to answer those questions in the meantime, but if you don't feel like reaching out, please tune in the next couple of weeks. We definitely want to make sure that we can get this information to as many code enforcement officials and planning and zoning board members as possible. So it's my sincere thanks to all of you for making time out of your evening for joining us here tonight. We'll hope to see you in the next couple of webinars, and take care. And my thanks to Jason and Paul for joining us this evening. Thank you, everybody.